Welcome, and in this lesson, we're going to talk about the concept of targets and how we can satisfy the objective boot into different targets manually. Now, you should know that at this point, you're welcome to use your VNC terminal into the linuxacademy.com Red Hat 7 Enterprise server, but there will be a point at the end of this lesson that we perform something that can only be performed with the Red Hat or CentOS or Fedora distribution installed on your desktop with something like VirtualBox or VMware Workstation, or if it's installed on the physical machine itself. However, that's going to be in the end, and everything else that we do here, you can do on a linuxacademy.com lab server. So first, let's talk about the concept of targets. Everything is managed on our system now by systemd. And when I mean managed, I mean our services are managed. It's the initialization process that's replaced sysvinit from older systems. Now, one of the advantages of systemd is the fact that it has parallelization boot up. In other words, in sysvinit systems, it would have to start a service one service at a time, where systemd allows us to boot multiple services and unit configuration files simultaneously in parallel in order for our system to boot much faster. Now, as I've mentioned in previous lessons, the concept of run levels has been deprecated. Generally, you would go into a run level depending on your system. If you were going into a graphical user interface, you see on my screen here, I'm inside of a graphical user interface. If you're on a VNC or on a desktop of Red Hat Enterprise 7 Linux, you are in a graphical user interface. If you are SSH'd into a terminal, you're probably in a multi-user interface. Well, the thing is that the graphical user interface, all of the services and components required for the graphical user interface to work are defined from a dependency grouping. A dependency grouping is a unit configuration file, and we're going to refer to those as target systemd unit configuration files. Now, there can be dependencies of systemd dependencies or dependencies of unit configuration files. So, for example, our multi-user unit configuration file, our multi-user target, could be a dependency for our graphical.target in order for it to start. So let's learn a little bit about this real quick. First, I want to see what available targets are installed on my system. And I can do that by typing systemctl list units, and I'm looking for a unit type equal to target. Now, if I want to see all of the different type of unit configuration files available, I could do a systemctl-t for type and help. And these are the different unit configuration files that are available on our system. And we're going to be working primarily with service and primarily with target. But let's say I navigate into my usr lib systemd system directory. Inside of here, we have a lot of our unit configuration files, primarily the unit configuration files that are shipped with our distribution. So if I were to take a look, I'm going to do a vim on my sshd.service target. And if I take a look at this, we see that this is a unit configuration file. Well, instead of writing startup scripts or bash startup scripts with the traditional sysvinit system, now what we do is we write actual services. This is an actual service unit configuration file. And what this is saying is that this unit is the OpenSSH server daemon. This unit is to start only after our syslog.target has been called. And our target is just a grouping of unit configuration files. So everything inside of our syslog.target needs to be started before our sshd.service starts. Everything inside of our network target needs to be started. Everything inside of our auditd.service target needs to be started. So by doing this, we can create dependencies and relationships and tell when a service should start. If I need a script to start only after networking service is enabled because it needs to communicate with the internet, well, then this is where I can deploy it. So this environment file, we're going to talk about a few of these options, and we're going to learn how to do this later on in the course. We're not going to go too in-depth on it. But exec start pre means before the service starts, execute this script. Upon starting, execute this command. When we issue the SSH reload command, that means issue this command. And we'll talk about the other options as we go along. Those are the common ones. Then down here we have this option group called install. This means wanted by multi-user target. That means that when we enable the service, which on Red Hat machines, in order for the service to start at boot time, we need to enable it. And so what that means is when we enable it, it adds itself to the multi-user.target unit configuration file. It makes it a dependency, which means when our system moves into the multi-user.target, then our unit configuration file is going to be called. So what does this mean for our sshd.service unit configuration file we're looking at? That means since this is enabled, anytime our system moves in or has a dependency that calls the multi-user target, then our sshd.service unit configuration is going to be called and started. That's how we are now starting and stopping services whenever we are on our system. That's how the systemd process is working. You're probably a little curious now on how do I know what dependencies I have in the multi-user target? Well, let's take a look at that. I can very simply find my dependencies by typing a systemctl list dependencies, and then I'm going to specify my target. So that could be multi-user.target. And inside of here, we see all of the services or other targets that are to be called whenever our system enters into the multi-user target. So that's how we know what services are to be started. So the concept of run levels, before we would place bash scripts inside of a run level directory. So whenever we entered that run level, those scripts would be executed. Well, now with systemd, because we've replaced the sysv init system with systemd, we have targets. So when our system moves into the multi-user target, this service is to be called. This service is to be started. All of these are to be started or called. And if you notice here, we have a basic.target. Well, we can create a dependency on another target. So all a target is a grouping of configuration files. So our multi-user target also calls the basic target and everything associated underneath the basic target, so on and so forth. That's how we view the unit configuration dependencies for a specific target. Now, if I were to type systemctl get default, that's going to show me my current target. So I'm in the multi-user target. Now, there's 4 common targets that we need to be aware of for this objective. First target is the multi-user target. The multi-user target means multiple users can be logged in on the system, and generally you're working at a command prompt or terminal, text-based interface, not a GUI-based interface. If you were inside of a GUI-based interface, you would be inside of what's called the graphical.target. Now, the graphical target, what that does is there will be a dependency. If we do a systemctl list dependencies, graphical.target, let's grep for multi-user target. Well, it has a dependency of multi-user target. So whenever we enter in our graphical target, everything underneath our multi-user target is also going to be started or called. Our graphical target is going to call systems and services that are needed in order for our system to boot inside of a GUI interface. So again, let's recap. We have multi-user target. Then we have a graphical.target. Then we have emergency.target. Emergency target boots us essentially into a root command prompt. We need to log in as the root user, and it mounts the file system as a read-only file system. The rescue target launches us into single user environment with the minimum requirements loaded in order for us to troubleshoot and fix issues on our system. And so that target again is rescue.target. These are the 4 targets that you're generally going to move your system in and out of. Now, there are many different targets on our system. The reason we have many different targets on our system is because a target is just a grouping of dependencies for unit configuration files, services, sockets, other targets. A target has to be specifically configured in order for you to move into that target or call that target at the command line, which we're going to get to. So there's actually a reboot target, I believe. And inside of our system here, if we do an ls and we grep for reboot, you'll see that we have a reboot target. So you would think, well, maybe I can just navigate into the reboot target and that's how I can reboot my system. Well, that's not how it works. Your target has to be specifically configured in order to allow your system to move in and out of the target. So in other words, here's a parameter in our unit configuration file for a target. This parameter says allow isolate. Well, isolating means move your system into that target, call all of the dependencies that are required for that target. So in order to isolate your system, we're going to learn a simple command. So this is going to satisfy one of the requirements, which is navigating into different targets. So I'm actually going to pull up, you would do this on your VNC desktop. I'm going to pull up my Red Hat desktop for my local running machine here. Currently, I'm logged in on my linuxacademy.com lab server. So I'm just going to open up another terminal for my local machine. So in order to go from one target to another target, I need to use the systemctl isolate command. Now this is what allows me to switch between targets. So I'll do systemctl isolate and then a specific target. So if I were to do the multi-user target, since I'm currently in a graphical user interface on my system, so I can see what I'm currently logged in as in my target by doing systemctl get default. It shows I'm in a graphical user interface because I'm on a local desktop here and I'm in a GUI, so I know I'm in my graphical target. Now, let's say I want to go ahead and change the target that I'm in. To change the target, I would do a systemctl isolate and then my target name. Now again, my target has to be specifically configured to allow me to move in and out of that target. So I'm going to move into the multi-user.target. So the question is what do you think is going to happen when I hit return or enter? Well, what's going to happen is my GUI terminal is going to close and it's going to take me to a command prompt and ask me to re-log in. So here we are at the command prompt. I'll log in as my root user and I'm inside of my regular multi-user target. Well, I want to go back into my graphical user target. So I'm going to systemctl isolate my graphical.target. That's going to start everything required for me to move into a graphical user interface as we see here. I'm going to go ahead and log back into my linuxacademy.com lab server so we can continue learning about targets on there. Now, how can we set the default target for our system to boot into? Well, I can do that by typing systemctl set default and then my target. So if I were to type multi-user.target and then reboot my system, do you think it would reboot into a graphical user interface? Well, the answer to that would be no. So let's go take a look at what happens when we create our default. If I head into the etc directory, then the systemd, then the system directory, we have here something called the default target. The default target is just a symlink to a unit configuration file that changes depending on our default. So you see here, it's been changed to go to our multi-user target located in the USR lib systemd. Now let's talk real quick about these different unit configuration locations. We have the USR lib systemd system directory. Inside of here is all of our system's unit configuration files that ship with the system. Now inside of the etc systemd system file is additional configurations. Additional configurations might include unit configuration files for programs that have been downloaded and installed, like the Apache program, or for custom configuration files that we're writing in our system for startup, custom services. And we would put those inside of here. Now, anything inside of the etc directory with the same name will actually overwrite anything in the USR lib directory with the same name. So everything in here started first, and then everything in the etc directory is called. So it looks at USR, and then it looks at our etc directory. And as you can see here, when I change back again, systemctl set default, I'm changing my default target for when my system reboots. I'm going to change that to graphical.target. We'll do an ls-l, and we'll see that our default is now going to our graphical target. So now that we learned about targets and how they're associated with systemd, we've learned that they're just groupings of unit configuration files. We've learned how to isolate our system to move into a selected target. We've learned how to set the default target at boot time using set default. We know we can look at the current default by using get default, and we can also list all of the dependencies for a target by using the list dependencies parameter on the systemctl command. Now, here is where something we can't use our linuxacademy.com lab servers for. This is something you'll have to use on a physical machine or on VirtualBox or VMware, Parallels, or whatever you're using on your local machine if you are using it. So pay attention, because if you don't have this on your local machine, it's okay. You just need to know how to do this. So this is one of those moments from when I talked about at the beginning of the course. Pay extra due diligence attention and memorize how to do it. So what I need to do first is I need to see my current default. My current default is the graphical.target. How can I interrupt the boot process and specify to go into an emergency target or rescue target instead of the graphical target, even though our graphical target is set as default? So to do this, I'm going to do reboot. So what I need to do is I need to interrupt the boot process at my grub menu. And I do that by hitting in key. So it takes away my boot countdown. Next, you see press E to edit the selected item. And this is the item I want to edit. So I'm going to hit E. Inside of here, we get basically some grub configuration. I'm going to browse down until I see this Linux 16 line. This is the kernel command line. I am going to go to the very end of this line, and I'm going to add a little bit of information. So I'm basically editing where the kernel's going to boot. So I'm editing my Linux 16 kernel command line here. So what I'm going to add is I'm going to add systemd.unit equals, and then the target that I want to boot into. For example, rescue.target. When I'm done with this, I'm going to go ahead and hit Control X to continue the boot process. You'll notice here I'm now inside of rescue mode. So I can Control D to continue the boot process, or I could have worked inside of rescue mode. So I continued the boot process, but if you notice, I can interrupt the boot process and specify a different target. So if we were to demonstrate this one more time, let's change it from loading into the graphical target and instead tell it just to load into the emergency target. Or in this case, let's go ahead and load into the multi-user target instead of the emergency target. But this is how we would navigate into the emergency target if we needed to. I interrupt the boot process. I hit E on the one I want to edit. I come down to my Linux 16 command line. I'll type systemd.unit equals and the target that I want to boot into. So for example, if I want to boot into the multi-user target, let's specify multi-user target and then hit Control X for it to take that configuration. You'll notice I'm now booted into the multi-user target. It's not a graphical interface, it's a regular interface. And if I want to go ahead and open up or move into my graphical interface and launching it, I could do a systemctl isolate graphical.target. So that concludes it for this lesson. Go ahead and complete this lesson and move on.